So, good afternoon. Welcome to Module 2 on the subject Introduction to Data Structures. So, in the last class, we had discussed about what is an array as it is data structure, and in the array, we have discussed traversal of the array elements. Traversal of the array elements. That is what we have discussed. And in today's class, in today's class, we will be talking on in the same arrays topic, the elements insertion and deletion. Array In an array, how to insert an element and how to delete an element. That is what we are supposed to discuss in today's class. And now, moving on to what is insertion and deletion. Insertion is a task of adding an element into an existing array, while deletion is a task of removing an element from the array. So you have already an array. So inside the array, you are going to insert an element, and the same way you are going to delete an element. So uh, you will going to delete the element based on the index position. So the point of insertion or deletion, that is the position where the element is to be inserted or deleted, holds the vital importance, uh, as we will see in the subsequent sections about this particular insertion and deletion. And moving on to this insertion, observe this diagram. If an element is to be inserted at the end of the array, then it can be simply achieved by storing the new element at the last position. So automatically what happens, you will going to insert an element at the end of the array. Okay, that is very easy. So you have the existing array, initialized array. If you want to store an element, new element, 4 is a new element that you have to store it at the end of the array. So what you have to do, you have to just simply traverse till the end of the array, and you store it. So that is very easy. However, the array must have uh, vacant position at the end. Very, very important thing. So if you declare the size of the array is 5, and already the 5 elements are there, you cannot insert. So you should have sufficient vacant positions so that the new element can be inserted. And alternatively, if an element is required to be inserted in the middle, if any element is required to be inserted in the middle, so then definitely what happens? The Suppose I want to insert an element, maybe at position number 3. So a of 3, I want to insert an element, 4 has to be inserted. So what you have to do, you have to move this 22 to the next cell. Before that, you should have moved 77 to the next cell, and later in the place of 22, 4 can be inserted. So there is new element which has to be inserted in between. So definitely it has to be taken. So at the end, insertion at the end is very simple. So what you have to do, you have to just go till the last, and you can certainly insert the new element. And whenever you think of inserting a new element at particularly location, index location 2, look at there, index location 2, I want to insert an element. So index location 2 means, so this location, that means 77 will be moved to the next, 22 will be moved to the next, and 5 will be moved to the next, and later the new element 4 is to be inserted here. So it is just like this. So that is what you have to move one place to the right, and later you insert it. And this figure 4.2 depicts the insertion of an element into an array. So that is, you have to understand this concept. It is quite necessary. And if you want to insert this, let us look into the algorithm first. So, algorithm, if you look at the algorithm, look at this. This is an algorithm. I have taken it as it is from the textbook. And this algorithm, you have to, 8-step algorithm, you have to understand. So, what you are trying to do is, in this algorithm, you are supposed to insert an element. The element which you are supposed to insert is called P. Is called the P. P is the element we have to insert. And it has to be inserted at an index location K. K is your index location. So index location, index position is your K. So in the array A of n, where n is the size of the array and K should be always, that is, the inserting element position should be less than the total size of the array. So now, what you are doing, insert is the name of the algorithm. For this, you are giving an array A of n with K, that is the position, and P is the inserting value, inserting value, inserting element. So what you do, you set I to n. So I is a variable which you set it to n, that is the last position. And you have to repeat step 4 5 until you have to move the elements, right? You have to move the elements towards right. That is the reason. So in this while loop, what you are doing, you are specifying until I is greater than or equal to K. So until it is K, so what you are doing, A of I, you are moving into A of I plus 1, that is moving to the right cell. So the element has to be moved one position to the right cell, and every time I will be decrementing. So if you have if you have an array like this, so if you have an array like this, and you know very well, so -1 is the initial array, 3 and 5, 22 and 77. So this is like this. And now what you have to do, you have to insert an element, that is P. So the element which you are supposed to insert is 4. 4 is the inserting element at position number 2. So this is 0, 1 and 2. So what you have to do, all the elements from the last, that is n, that is the last, it has to be moved. So 77 will move on to the next. So A of I, that is 77, it has to be moved to the A of I plus 1. So 77 is moved here. 77 is moved, and is moved. And what happens, uh, so this place becomes empty now. uh, Now, what happens? 22 has to be moved. So, 22 will move to this position, 22 will move to this position, and 5 will move to this position. So, that, so your 5, this position is empty, and of course, uh, there is a free space. Now, as soon as you move, that is until the K position, this is the K position, this is the K position. So until the K position, you move all the elements, you move the all elements. Now after you, it is done, after you move all the elements, so K becomes free. Now A of K is equal to P. The P is the element, P is nothing but it is the fourth element. So the 4 is stored. So at a of k is what your 2. So that is the index position. So this is how you can certainly do it. And now the number of elements are increased by 1. So what you do, you set n is equal to n plus 1. So you can certainly do that by setting n is equal to n plus 1. You can certainly increase and you can stop. So this is the algorithm. This is the algorithm to insert an element into an array. Of course, programmatically, what you have to do, you have to first initialize the same array. Okay, array is initialized and all the elements are present. Now, I is for iteration, k is for the position of the element where it has to be inserted, n is the total size of the array, and p is nothing but the inserting uh, element. Inserting element, k is the position, p is the element. First, what you do, you display what are all the elements that you have. So all these elements are displayed. So one by one they are displayed. So here, so minus 1, 3, 5, 22. So before insertion, so they are displayed. So 77, all are displayed. Now take the position. So where it has to be, take the element. What is the element to be inserted? And take the position. So P is the element and K is the position in which it has to be inserted. In the next slide, what you do, you shift all the elements till position k towards right. So that's why you say for I is equal to n, the last position, and I is greater than k. So every time a of I, you are moving to a of I plus 1, you are moving it until the k position, you are moving all the elements, so that in the k position there should be some space for a new element to be inserted. So you can insert element p. So array of k is equal to p, you insert it and you increase the total number of elements in the array, and finally you display it. The same thing you can execute it. The same thing you can execute it using this link, execution link. So you can certainly check it out. It is, yeah, it is executing. So I'll just bring it here. Yeah, yes, it is same program I have typed in. It is ready for execution. Now the input, the entering the element. So I'll going to give the element as 33 to be inserted at the last position, position number 5. So position number 5, so I have to insert 33 has to be inserted to the position 5. So you run it. So as soon as you run this code, so what happens, initially minus 1, 3, 5, 77 were there. Initially they were there, and now uh, now what happens, 77 were there. Now, what happens after this? You are trying to insert the element 33. You are trying to insert the element 33. So, in position number 5, yes. So, 0, 1, 2, 3, 4, 5. In the position number 33, you have inserted. Now, I want to insert at the beginning. So, what I'll do, I'll make it a 0. So 33 has to be inserted at position number 0. So what if you want to insert at the 0 position, what happens? All the elements, 77 has to be moved to the next, 22 to the next, 5 has to be moved to the next, 3 has to be moved to the next, minus 1 has to be moved next, and finally this 33 has to be inserted. So for this, let me run this code. So as soon as I run this code, so what happens? Yeah, 33 is inserted at the beginning. So this is the code. Now I want to insert 33 not at 0 position. I want to insert at position number 3 or position number 2. I want to insert at position number 2. So same 33. as soon as I run this code, so what happens? You observe. So yeah, 0, 1, 2. So it is inserted at the position number 2. The same program you can also execute. I'll just give uh, I'll paste it in the chat box, so you can certainly use it. So I'll paste it in the chat box. You can also certainly execute this program and check it out. So how exactly it will work. So you can understand how exactly you can run this code. Now, the same program, the same program. Now, I want to visualize how exactly it has to be executed. So, what I'll do, I'll just click on Visualize Code. So, another web page it opens. Yeah, another web page it opens. So, where you can visualize the same program I have given here, and I have specified P as 33 and K as 0. 0 means at the starting position. Now, whenever I run this code, whenever I run this code, so what happens? Whenever I run this code, what happens? Initially, the array is initialized. Observe here. So rest of the elements are available. Zeros. Next. So n is equal to 5, and you are displaying all the elements. So 1, 2, 3, 4, 5, all the elements you are displaying. You can see here, it is displayed here, all the 5 elements. Now, your element to be inserted is 33, you have already given, and your position is 0 position. So it is to be position 0. Now, what you are trying to do, observe now. Observe now, 0 position means all the elements. 77 has to be moved to the next cell. 22 has to be moved to the next cell. 5 has to move to next cell. 3 has to move to next cell. So 0 position, your 33, the new element which is coming in, it has to be inserted. So for this, look at there. So I'm inserting 77, next 22, next 5. So 3 minus 1 is done. Now, after that, in the first position, there is 0 position, I'm inserting 33. So like this. So I have inserted 33 at the beginning. So at the beginning. So this is how I have inserted at the beginning. And finally, after inserting, I'll display all the elements. So 33 minus 1 minus 3, 5, 22, and 77. So obviously. So this is but if I want to insert at some position, not at 0 position, I want to insert at position number 2. I want to insert at the position number 2. Let us see how exactly it has to be done. Let us see how exactly it has to be done. So you visualize the code. So you can just check it out how exactly it is visualized. So you create an array, and of course, so the all the elements in the array are displayed. Now the inserting element is 33 at position number 2. So now you move uh, all the elements. 77 you move it here, 22 you move, 5 you move up to the position number 2, all the elements you move it. So as soon as you move, you can see 22 is moved, next 5 is moved, and at position number 2, the element 33 is inserted. Look at that, and n is incremented by 1. So earlier it was 5, now it has become 6. So now you can display all the elements. You can display all the elements after insertion. This is before insertion, this is after insertion. You can certainly display them. So you can display them like this. You can display them like this. Similarly, the last position also, you can certainly display them in the last position also. So that is how it has to be understood, visualized, and of course the visualization link I'll be just uh, posting. So I just copy this and I'll put it in your chat box, so that you can also simultaneously run this code. You can also simultaneously run this code. So this is the and program analysis. Whenever we do program analysis, that's what we are doing. Mainly this for loop, you should not forget. It's a main important thing. What you are doing, it shuffles the array elements towards, it shifts, actually it shifts, it's not shuffles, shift the array elements to the right, uh, uh, to create space for inserting a new element. And once that is done, next is it inserts and it increments the total number of elements in the array by 1. So that is the thing. Now, coming on to deletion of elements. So whenever you think of deleting of an element, the deletion of elements follows a similar procedure of insertion. So the deletion of element from the end is quite simple, and it can be achieved by mere updating the index, of the identifier. However, to remove an element, so if you want to delete the element at the end, so it's very simple. So n you update it to 0, 1, 2, 3, 4. That's it. Make it n as 4. So automatically what happens? Sufficient. So that last element, even though it is present in the memory, that is not taken care. So you can take it is removed. Okay, it is automatically removed. So it is the same. But if you want to delete an element in between, so that is at from an index position exactly. So however, to remove an element from the middle, one have to move all the elements to the left. In the previous case, you are moved to the right. Now you have to move it in the reverse direction. That is towards right. You have to move. So suppose I want to move 5. I want to delete 5. So what I have to do? I have to move 22 to 5 position and 7 to 77 to 22 position. So by doing so, what happens? You are going to delete. So you are moving towards the left. So that is the thing. So move all the elements to the left of the point of deletion, the position. So that is what you have to do, and it is very well depicted in this diagram. You can certainly understand. So the algorithm goes like this, very simple. So uh, your algorithm is named as delete, and AFN is the array, and K is the position, and D is the deleting element. Okay, D is the deleting. Now, set D is equal to A of K. This element you are deleting. So, you're first storing D in the D. Now, set I is equal to K. I is equal to K. So, if you are trying to delete an element, so probably, so this is the element that you are deleting. So, this is the element that you are trying to delete. So, what you have to do? So, this you call it as I. So, I will be moved on to K, and until I reaches n minus 1, what you have to do? You have to set A of I is equal to A of I plus 1. A of I plus 1, that is the next cell, it has to be A of I. That means you have to move it like this. Next, I plus plus, move to the I. I will be moved from here, this position to this position. Now, I is here. Now, A of I plus 1, that is the next cell, it has to move to A of I. So it is done like this. So like this, you move until you reach the last position. And after you move all these elements, what happens? The element is automatically deleted, and you set n is equal to n minus 1. So set n is equal to n minus 1. So that is, you are reducing the number of elements in the array. So that is what you should understand. The program also the same. Look at here. This is the initialized array, and your k is the position, n is the number of elements in the array, and d is the deleting element. So what you do, first you display all the elements, and you take the k position as an input, which element you are supposed to delete. So you input the k position value. Once you take, so array of k, this is the one you are supposed to delete. So make it as d, just for our reference. That's all. Now you move I from k, and it has to go up to n minus 2. So that is, it has to move all the elements, all the elements it has to move. And finally, once they are moved, so here what you are doing, as you are moving you are deleting. So you are deleting as you are moving it. As you are moving the elements, you are deleting the elements. And of course n is equal to n minus 1. So the total number of elements are reduced by 1. And after that, after deleting, you're displaying all the elements of the array. So same program, you can execute it. So I'll just show you the code to execute, and it is loading it. Yeah, you can see the same program is available here. Yeah, the same program. So now I'll understand the array. Whatever I have, the array is minus 1, 3, 5, 22, and 7. Now I am trying to delete this last element. I want to delete the last element, that is 77. So 0, 1, 2, 3, 4. So 77 I have given. And as soon as I run it, so the fourth element 77 I have given. So as soon as I run it, so what happens? The element 77 got deleted, and it is not there. It is not displayed now. Now, what I do, I don't want to delete the last element. I don't want to delete the last element. I want to delete the first element, that is zeroth element. So you just run it. So as soon as I say run, what happens? It will automatically, the first element minus 3 got deleted. Sorry, minus 1 got deleted. You see, because I have given the space, given the input, deleting input element input position as 0. So what is thing? Now I'll give the input as 2. So 2 means 0, 1, 2, that is 5 has to be deleted. So now let us run it. So as soon as I run it, so what happens? Yeah, 5 got deleted. So this is how the same. So the program, whatever we have discussed here, as you are moving the elements from f I plus 1 to I, that is you are moving to the left, so that you're deleting the element. You're deleting the element. The same link I'll be sharing in the chat box, so that you can also straight away execute it. And not only that, so you can also visualize this program. You can also visualize this, how exactly it is moved. If you want to know, you can certainly visualize this code. So I'll just executing this visualization code. Yeah, the code is getting ready, so you can see. So it is getting ready. Yeah, it is getting ready. Yeah, now, sorry. Yes, now observe, now everything is empty. As soon as I populate, the array gets elements get created. Now n is equal to 5. Now I want to delete the element. So first I'm just printing all the elements. So in this line number 10 and 11, what I'm trying to do is I'm deleting all the elements. Now I'm asking for the element to be deleted. I want to delete the first element, k is equal to 0, the first element. As soon as I see first element, the deleting element k is equal to 0. This first element is minus 1. Minus 1 has to be deleted. So I'll create another for loop. I'll move. So all the elements, you can see 3 I have moved to first element. Now I'll move 5. I'll move 5 to the 3 position, 22 to 3 5 position, and 77 to position. And so after this, I'll reduce n is equal to n minus 1. I'll reduce it. And finally, what I do, I just display all these elements. So as soon as I display all these elements, the first element got deleted. Same way, if you want to delete the second element, what I do, you can make k instead of 0, you make it as 2. And you try to visualize them the same way it happens. Same way it happens. And of course, you can see it is getting ready. So yeah, this is ready. And you can certainly first, what you are trying to display all the elements of the array. And once it is done, so you are trying to delete the second element, second index position element, that is 5 you are supposed to delete. So in this case, so you are trying to move. And finally you are trying to display them. So you can see, so as soon as you display them, it is the except the second index number, that is 5, everything is present and it is moved. And number n is reduced by 4. So 0, 1, 2, 3, 4. Even though 77 is there in the fifth position, so it is not taken. It is not taken. Only 0, 1, 2, 3. That's all. Only 4 elements are there. It will take. And this is how the execution happens. And the same program code I'll be just pasting in the chat box. You can certainly understand. You can also execute this program by varying it. And that's the program for deleting an element uh, from the array. I've taken this program from your textbook. Straight away from your textbook it is given. And program analysis. So you retrieve the element that is to be deleted, that is d is the element that is to be deleted. You shuffle the array elements, or you shift the array elements towards left by filling the vacant space created after deleting the array element. And finally, after doing that, you reduce or you decrease the total number of array elements by 1. So these are the main uh, key statements that will going to delete an element in the array. So that's all for today's class. In the next class, same arrays will continue with some more operations. So as I said, data structure is nothing but it's a collection of data plus operations. So far we have seen 3 operations. One is traversing, another one is insertion, another one is deletion on the arrays. Now in the next class, we'll be discussing about searching and sorting. Searching and sorting of the array elements. So that is there in the next class. So kindly type in your USN in the chat box if you have not typed. So it is very important for the record of attendance. And of course, thank you so much. All the class recordings are available in this particular online resource website. So you can certainly use them. Thank you. Have a wonderful day. If you have any doubts, you are most welcome to